Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. I also took my Bachelor's of Science at this institution as well in the Pharmaceutical Chemistry program. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions in today's session. Alright, so question number 1 asks, what are the alkali metals? Alkali metals. So I'll just write out some of their properties and kind of like what they are. So obviously they're metals and they can be found from the S block of the periodic table. And also they can appear silvery, and they are also highly reactive at standard pressure and temperature. So alkali metals are also known to readily lose their outermost electron to form cations. So if you don't remember what cations are, they're basically positively charged ions. So some of examples of alkali metals are like lithium, sodium is a common one, and like potassium. Okay, so let's see what the junior tutor said. Alkali metals are elements located at group 1A of the periodic table of elements, excluding hydrogen. These include lithium, sodium, potassium, rubidium, cesium, and francium. So they have here it boxed out with the exception of hydrogen. Elements belonging to this group have one outer valence electron, which they can easily give off since it has a low ionization energy to achieve a steady, stable state. This low ionization energy causes an energetic reaction. You can see how some of these elements behave when they put it in water. And they give a cool YouTube video link. Okay, so this solution is correct. Great explanation. Okay, so moving on to question number 2. How do you calculate KSP from molar solubility? Okay, so KSP from molar solubility. Okay, so first I'll write out the definition of molar solubility. Okay, so molar solubility is the number of moles that dissolve per liter of solution. Okay, so I am going to write out an example on how one would calculate KSP when given molar solubility. Okay, so for example, let's say we had calcium fluoride. Given its molar solubility is equal to 2.14 times 10 to the negative 4 moles per liter. Okay, so step 1 on answering these questions is to write out the chemical equation for the substance dissociating. Okay, so in the case of calcium fluoride, I'll put it as a solid. And then I'll show it dissociating into its ions. So its ions would be calcium 2 plus and also 2 fluorine minus. Okay, so that is step 1. Step 2 is to write the KSP expression. Okay, so in this case, KSP is equal to the concentration of the calcium 2 plus multiplied by the concentration of the fluorine ions to the power of 2, since there is a coefficient of 2 in front of the fluorine in the balanced equation. Okay, so that brings us to step 3, which is just to insert the concentrations of each ion, so calcium and fluorine, and solve. So since there's a 1-to-1 molar ratio for calcium fluoride and the calcium ion, then we know that they will have the same concentration, which is 2.14 times 10 to the negative 4. In the case of fluorine, since there is a 1-to-2 molar ratio for calcium fluoride and the fluorine ion, I need to multiply the 2.14 times 10 to the negative 4 by 2. So 4.28 times 10 to the negative 4, and that is to the power of 2. And we get a final KSP value of 3.92 times 10 to the negative 4. So let me just add like a note here. Since the CaF2 ratio is 1 to 2. Okay, so let's see what our junior tutor said about this question. The solubility product constant KSP is the equilibrium constant for a solid substance dissolving in an aqueous solution. It represents the level at which a solute dissolves in a solution, and it is used to describe the saturated solutions of ionic compounds with relatively low solubility. Saturated solution is in a state of dynamic equilibrium between the dissolved, dissociated ionic compound and undissolved solids. For a general chemical equation, they have MXAY solid, and then they show that the subscript of M becomes its coefficient, and the charge that it has is the coefficient of the A. And then they show the same thing for the anion. The general equilibrium constant for such a process can be written as, and then they show the general expression for that. Concentration of M ion, concentration of A ion, and also X and Y are the coefficients of the ions in the chemical equation. On the other hand, molar solubility is the number of moles that can be dissolved per liter of the solution before the solution becomes saturated. Once a solution is saturated, any additional solute precipitates out of the solution. So, in a sense, molar solubility is the molarity of the saturated compound. Say, given the molar solubility of the compound, you can determine the concentration of the products after the dissolution of the compound using the balanced chemical equation. Then the concentration of the products will be used to calculate the solubility product constant of the compound. Okay, so this solution was correct. Very in-depth explanation. Okay, so moving on to question number 3. Calculate the molar mass of each of the following compounds. So first we have iron 3 oxide. If the molar mass of iron is 55.85 grams per mole, which we can find on the periodic table, and the molar mass of oxygen is 15.99 grams per mole. So now I can write out the molar mass of iron 3 oxide to be equal to 2 times 55.85, since there are 2 atoms of iron in the compound. Then I'm going to add 3 times 15.99, which shows that there are 3 atoms of oxygen in the compound. Okay, so adding these values up, you get a total molar mass of 159.7 grams per mole. Okay, on to B is boron trichloride. So the molar mass of boron is 10.81 grams per mole, and the molar mass of chlorine is 35.45 grams per mole. So the final molar mass would be 10.81 grams per mole, plus 3 times 35.45. And you should get a final molar mass of 117.2. And for the last question, part C is ascorbic acid. So it's C6H8O6. So the molar mass of carbon is 12.01. The molar mass of hydrogen is 1.01. And I already wrote out the molar mass of oxygen up there, and it's 15.99. Okay, so now I will write out the total molar mass of ascorbic acid. It's going to be 6 times 12.01. Oops. Plus 8 times 1.01. And then lastly, plus 6 times 15.99. Then you get a final molar mass value to be equal to 176.1 grams per mole. Okay, so let's see what the junior tutor said. The molar mass of a compound is the sum of the atomic masses of the individual elements consisting of the compound. They have 159.7, 117.2, and then 176.1 grams per mole. So this solution is correct. Okay, so moving on to question number 4. What is the molar mass of urea? Okay, so let me write out what the structure of urea looks like. It looks like this. There's a double bonded oxygen and 2 amine groups. So its formula is 1 carbon, 4 hydrogens, 2 nitrogens, and 1 oxygen. So molar mass is equal to the molar mass of carbon plus 4 times the molar mass of hydrogen plus 2 times the molar mass of nitrogen plus the molar mass of oxygen. Again, you just need to find these different atomic masses on the periodic table. For carbon, it's 12.01 grams per mole. For hydrogen, it's 1.01. For nitrogen, it's 14. And lastly, for oxygen, it is 15.99. Okay, so adding up all these values, you get a total molar mass of 60.06 grams per mole. Okay, so let's see what the junior tutor said. Urea has a chemical formula CH4N2O. To get its molar mass, multiply the molar masses of each element by the number in their subscripts and add them all up. Carbon 12.01, hydrogen 4.03, nitrogen 28, oxygen 15.99, and they got a total of 60.06. So I can verify that this solution is correct. Okay, so moving on to question number 5. What is the mole ratio? So I'll just write out the general definition of a mole ratio. Basically, it is a conversion factor that relates the amount in moles of any two substances in a chemical reaction. I'll also write like a little note. Basically, you can find the mole ratios by looking at the numbers in a chemical formula. That comes from the coefficients. Okay, so let's write down an example. Let's say you had nitrogen gas plus hydrogen gas makes NH3. Okay, so let's balance this equation. There is 2 nitrogens in the reactant, so I'm going to write a coefficient of 2. And now there are 6 hydrogens, so I am going to write a coefficient of 3. And now the equation is balanced. If I were to find the molar ratio of nitrogen to hydrogen, I would simply just look at the coefficients after the equation is balanced, and I'll see that their ratio is 1 to 3. So therefore, we can say that you need 3 moles of hydrogen to react with 1 mole of nitrogen. Again, from this equation, if I were to try to find the molar ratio of hydrogen to NH3, let's look at their coefficients. It would be a molar ratio of 3 to 2. So this shows that 3 moles of hydrogen is needed to produce the 2 moles of NH3. Okay, so let's see what the junior tutor said. Mole ratio is used when we want to convert the moles of one substance to another. This is used in stoichiometric calculations. For example, given a chemical equation, lowercase a, b makes c, d, the mole ratio to convert a mole of B to C would be whatever coefficient of mole B divided by the coefficient of C for mole C. Yep. So this solution is correct. Okay, so the next question just asks, what is a conversion factor? Okay, so simply putting it, it's something we use to convert one unit to another unit. So let's say in 1 liter, there are 1,000 milliliters. Yeah, so there's a lot of different examples of this. I'll see what the junior tutor said. Conversion factors are useful tools in science to convert one unit to another unit. A lot of conversions are present in problem calculations in sciences like chemistry and physics. This is a big help when dealing with dimensional analysis. For example, if we want to solve for the molarity of the solution, we will be needing the number of moles of the sample and the volume of the solution, which must be in terms of liters. If the problem gives us a unit of volume milliliters, we will be needing to convert this measurement from milliliters to liters. Here enters the conversion factor. Conversion factor of liters to milliliters is 1000 mils is equal to 1 liter. So say, for example, you have 250 milliliters of solution. This measurement can be expressed in liters by conversion. So here they show it 250 dividing by 1000 to get 0.250 liters. Okay, so it's a pretty simple example, and it all makes sense, so this solution is correct. Okay, so moving on to question 7. What is an aromatic compound? Okay, so aromatic compounds contain one or more rings with pi electrons so there are pi electrons when there are double bonds or triple bonds in the ring. So these pi electrons are delocalized all around them. So the most common example would be benzene. So benzene is an aromatic molecule. It is comprised of a 6-membered carbon ring. Did I write this? Oh. I'll just write out the hexagon. There. Couldn't draw shapes. And basically, benzene has 3 double bonds, and in between each double bond is a single bond. Okay, so let's see what the junior tutor said. Aromatic compound is an unsaturated organic substance whose structure contains at least one planar ring joined by covalent bonds. Examples of aromatic compounds are toluene and phenol. Okay, so you'll notice that all of the different aromatic compounds that they have in the example all contain a benzene ring. You have toluene, phenol, aniline, acetophenone, benzaldehyde, benzoic acid, benzonitrile, orthoxylene, and also styrene. Okay, so this solution is correct. I'll also add that Okay, so moving on to question 8. What is the formula mass of water? So water, as we all know, is simply just H2O. I guess that's all the question was asking for. The chemical formula of water is H2O. It consists of 2 hydrogen atoms, 1 oxygen atom. Hence, its formula mass is equal to 2 times 1.01 plus 16, which is equal to 18.02. No formula mass, yeah. Yep, so that is correct. You write that here. So they did that by multiplying the atomic mass of hydrogen by 2 and just adding the atomic mass of oxygen. And they got 18.02. Okay, so the solution is correct. Okay, question number 9 asks, what is the molar mass of water? So this is pretty much the same question. So I'm just gonna leave this screen up. 8/9. Let's see what this junior tutor said. Calculating molar mass of a compound. The molar mass of each element is multiplied to the number of atoms and summed up. Molar mass of each element can be obtained from the periodic table, and the number of atoms is indicated by the subscript of each element in the chemical formula. Chemical formula of water is H2O, hence its molar mass is 18.02. So this is also correct. Okay, so on to question 10. What is the molar mass of calcium carbonate? Calcium carbonate. So if you don't know the chemical formula for calcium carbonate, let's try to analyze what it contains. So it contains a calcium ion, which is Ca2+. And carbonate is an example of a polyatomic ion, and I will draw out its structure. There's a negatively charged oxygen bonded to a carbonyl, bonded to another negatively charged oxygen. So we can see that its formula would be calcium CO3. So let's find out its molar mass. First, we'd need the molar masses of calcium, the molar mass of carbon, and 3 times the molar mass of oxygen. Okay, so these are the values that you would just find on your periodic table. For calcium, it is 40.08 grams per mole. Molar mass of carbon is 12.01 grams per mole. And lastly, the molar mass of oxygen is around 15.99 grams per mole. So if we were to add all these values up, we end up with a total molar mass of 100.09 grams per mole. Okay, so let's see what the junior tutor said. Molar mass of calcium carbonate is 100.09 grams per mole. Step 1, identify the elements present. Step 2, list the number of atoms per element. Step 3, look for the individual molar mass in the periodic table. Step 4, multiply the number of atoms by the individual molar mass and add them up. Yep. That was a cool step-by-step explanation. Okay, on to question number 11. What is the molar mass of aluminum? Basically, you just really need to look this up on the periodic table, and it is 26.982 grams per mole. Okay, so let's see what the junior tutor said. Molar mass of an element is the same as its atomic mass. This can be easily seen in the periodic table. Molar mass of aluminum with chemical symbol Al, so you can't really see it, but it would be here, is equal to 26.982 grams per mole. Okay, so this solution is correct. On to question number 12. What is the molar mass of copper ammonium sulfate? So they give us the chemical formula already. So it looks a little more difficult than our other questions on molar masses, but we can just break it up into parts. Its molar mass would simply be the molar mass of copper plus 4 times the molar mass of nitrogen. Okay, so you can see that there are 4 hydrogens inside the bracket, but the NH4 also has a subscript of 4, so that means there are 16 hydrogens altogether. So 16 times the molar mass of hydrogen plus the molar mass of sulfur plus 4 times the molar mass of oxygen. Okay, so now we just have to look up these values in a periodic table. The molar mass of copper, 63.55. The molar mass of nitrogen is 14.01. Molar mass of hydrogen is 1.01. The molar mass of sulfur is 32.07. And lastly, the molar mass of oxygen is 15.99. Okay, so plugging up all these values, you get a final molar mass of 231.8 grams per mole. Okay, so let's see what our junior tutor said. To calculate the molar mass of a compound, the molar mass of each element of the compound is multiplied to the number of atoms and summed up. Molar mass of each element can be obtained from the periodic table, atomic mass, and the number of atoms is indicated by subscripts. Based on the chemical formula, copper NH4 SO4, 1 copper atom, 4 nitrogen atoms, 16 hydrogens, 1 sulfur, and 4 oxygens in the compound. And they also got a total molar mass of 231. So this solution is correct. Okay, so next is question 12. What is the formula for barium phosphate? Okay, so barium is made up of the ion barium, which has a charge of 2+, and phosphate is an example of a polyatomic ion. Its formula is PO4, and it has a charge of -3. So its chemical formula would be barium 3 PO4 2. Okay, so let's see what the junior tutor said. Formula for barium phosphate is Ba3PO4 2. Barium phosphate is a salt compound formed from barium cation Ba2+, and phosphate anion PO4 3-. In writing the chemical formula of a salt compound, we simply take the charge of the cation as the subscript of the anion, and the charge of the anion as the subscript of the cation. So what they mean here is that an easy way to figure out the subscripts, you'll see that the charge of barium is 2+. So therefore, the subscript of the PO4 in the final formula would be 2. And in the case of phosphate, has a charge of 3-. So then we would need 3 bariums to neutralize it. So this solution is correct. Okay, so on to question number 13. Just simply asks, what is the molar mass of iron? Okay, so you can just find this on your periodic table, and it is 55.845 grams per mole. Junior Tutor said molar mass of iron is 55.845. Molar mass is the mass of a given chemical element or chemical compound divided by the amount of substance, usually in terms of moles. Molar mass of any substance is numerically equal to the mass of that substance expressed in atomic mass units. The atomic mass units are easily found in the periodic table. By looking at the periodic table, the molar mass of iron is 55.845 grams per mole. Okay, so the solution is correct. Just another simple molar mass question. Question 14. What is the molar mass of sodium hydroxide? So if you don't know the formula of sodium hydroxide, basically it is NaOH. So to calculate its molar mass, it would just be the molar mass of sodium plus the molar mass of oxygen plus the molar mass of hydrogen. Since there is one of each of these atoms, we don't need to multiply them by any subscripts. So the molar mass of sodium is 22.99. Molar mass of oxygen is 15.99. And the molar mass of hydrogen is 1.01. Add all these values up, and you get a final molar mass of 40.0. Okay, so our junior tutor said, in calculating the molar mass of a compound, the molar mass of each element is multiplied to the number of atoms and summed up. The molar mass of each element can be obtained from the periodic table, or atomic mass, and the number of atoms is indicated by the subscript of each element in the chemical formula. Chemical formula of sodium hydroxide is NaOH, hence its molar mass is equal to 22.99 plus 16 plus 1.01 equals 40. So this solution is correct. Great explanation. Okay, so question 14 asks, how can I calculate the specific heat capacity of water? So to answer this question, we would use the equation Q equals mc delta T. Okay, so I'll define what each variable means. So Q is the same as heat. So it can be heat absorbed or heat released. Absorbed or released. the reaction. And its units are usually in joules, or it can be given in kilojoules, and you have to convert. M is simply just the mass, and it is given in grams. C is what the question was asking about. It stands for the specific heat capacity. And finally, delta T can be defined as the temperature change. So basically, a question might give you two temperatures, the final temperature and the initial. So delta T would just be equal to T final minus T initial. Okay, so let's see what the junior tutor said. The specific heats of a substance is the amount of heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius. The unit of specific heat is joules divided by grams times this degrees Celsius. So I'm going to write that down. I forgot to put the units here. As the junior tutor said, it is in joules divided by grams times degrees Celsius. To calculate this, we perform calorimetry. Recall that calorimetry is the measurement of heat changes. Equation that relates heat to the specific heat is shown in equation 1. So S should really read out to be the variable C. So I'll just write a note, but this is the correct equation. Equation 1, Q is the heat absorbed or released by the reaction. M is the mass of the substance in grams. So this should be C is the specific heat, and delta T is the change in the temperature of the substance. So to get the specific heat, we manipulate equation 1. This is shown below. Yep, so then they show how you would solve for the specific heat of a substance. So this solution is correct. However, the variable for specific heat capacity should read C instead of S. But the explanation was all correct, so I'm just going to say this solution was correct. Question 15 asks, what is a glycosidic linkage? So a glycosidic linkage is a covalent bond that joins a sugar molecule to another group. So it doesn't necessarily need to be another sugar molecule. I'll show out an example, but you can kind of tell that this definition involves a sugar since it has a prefix of like glycose, which you can relate to with glucose. So I'll draw out an example. So let's say we had a glucose molecule, which looks like this. With all these alcohol groups. And I wanted to add it with ethanol. its final structure would look like this. But instead of where you would have this alcohol, I'm going to show where it is bound to the ethanol to form that as the final product, plus water as a byproduct. And then I'll label the glycosidic bond to be right here. Okay, so let's see what the junior tutor said. Glycosidic linkage is a bond that links two monosaccharide units through oxygen atoms. It is formed through each hydroxyl of a sugar. Yep, so the solution is correct. I'll also just add a side note that it doesn't necessarily need to be two monosaccharide units. I'll just say to another group, since I have an example where it is just added with an ethanol. Okay, so on to question number 16. What is the molar mass of benzene? Okay, so I'll write out the structure of benzene. It is a 6-membered carbon ring. And there is a double bond in between every other carbon. And each carbon has a single bonded hydrogen. Okay, so let's count out the carbons. There are 6 carbons and also 6 hydrogens. So to calculate the molar mass of benzene, it's simply going to be 6 times the molar mass of carbon plus 6 times the molar mass of hydrogen. So if we were to look up their values on the periodic table, the atomic mass for carbon is 12.01 grams per mole, and the molar mass of hydrogen is 1.01 grams per mole. Okay, so adding up all these values, you get a final molar mass of benzene to be 78.12 grams per mole. Okay, so the junior tutor said, in calculating the molar mass of a compound, the molar mass of each element is multiplied to the number of atoms and summed up. The molar mass of each element can be obtained from the periodic table, atomic mass, and the number of atoms is indicated by the subscript of each element in the chemical formula. Chemical formula for benzene is C6H6, 6 carbons, 6 hydrogens, hence its molar mass is C 12.01 times 6 gives you 72.06. For hydrogen, 1.01 times 6 gives 6.06. Okay, so they added those values up and also got 78.12. Okay, so I can verify that this solution is correct. Okay, so I think we have time for one more question. What is the formula mass for sulfur dioxide? So sulfur dioxide. Let's try to analyze its name so we can write out the chemical formula. So it contains a sulfur, and since there's di in front of the oxide, we know it contains 2 oxygens. Okay, so I'll write out an expression on the molar mass of sulfur dioxide. It would simply be the molar mass of sulfur plus 2 times the molar mass of oxygen. Since there are 2 atoms of oxygen in sulfur dioxide, you would just look up these values on the periodic table. For sulfur, it is 32.07 grams per mole. And for oxygen, it is 15.99 grams per mole. Adding these values up gives us a total molar mass of 64.07 grams per mole for sulfur dioxide. Okay, so the junior tutor said the molar mass of sulfur dioxide, SO2, is 64.1 grams per mole. Step 1, determine the molar mass of elements present using the periodic table. 32.065 grams per mole. Oxygen, 16 grams per mole. Step 2, multiply by the subscript of the element. 1 times 32.065 is the same thing. And oxygen is 2 times 16, which is 32. Step 3, add it all up. Molar mass of SO2 is 64.065 grams per mole. So this solution is correct. Okay, so that is all for the questions for today. And if you like today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit a question of your own, then check out the links in the description. And also, if you enjoyed today's video, go ahead and give it a thumbs up and a comment. And don't forget to share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.